So start with some basic things. First we will do vectors and coordinates. Cartesian systems, coordinates, positions, vectors. Now first starting with vector. We will talk about the first thing, which is projection or component of a vector are along any L-cape direction. So what is projection? Projection means, let's say there is a vector here from A to B. We will write this vector from A to B as BA vector. We will read BA vector as B from A, vector B from A. Now if there is a line, this is a line L, then if I take rays falling perpendicular to this line, there are rays falling perpendicular to this line, then in that case this point will get joined with this line by a ray falling here, which is at 90 degree with this line. Let's say this intersection point is A dash. Similarly, a ray falls here with 90 degree here. This point is B dash. Then this vector here, this vector will be called as the projection of AB vector here. A dash B dash A dash vector will be called as projection of BA vector along line L. So this is what the projection of any vector means. We take the projection of this by assuming that there are rays falling perpendicular to it. Then this is what the new length looks like, and the direction points along the line. So if I take a vector here, and let's say this is the vector here R, and this is the line, then if it makes theta angle here, then I will draw a perpendicular line here, and this length will become R cos theta, and the direction would be along this line in this direction. If I take along a line again, this is our vector again. Now this makes theta angle with this line here, this one, and this vector has a component. This vector has a projection length equal to R cos theta, and the direction is now in this direction. So the direction of projection depends on the line and the vector also. Now there is simple formula for writing a vector projection, which is equal to R vector dot L cap into L cap, where this is R vector and let's say this is L cap. This makes theta angle here with L cap, and theta is equal to smaller angle between L and R vector. Means this is also an angle and this is also an angle between these two vectors, then we will choose the smaller angle. between R and L. So this is how we will write projection. And now the second thing is sum of vectors. Sum of vector, that is A plus B. This is the sum of vectors. This can be written as, let's say, any R vectors. The sum of these two vectors is any R vector. And let's say this is A vector, this is B vector. They make theta angle between them. And this is any R vector resultant. This is beta angle with B vector, and this is alpha angle with R vector. Then we say that magnitude of R vector, or the sum of these two vectors, that is equal to A square plus B square plus 2AB cos of angle between A and B, which is theta. And if I want to write the tan beta angle, if I want to find the beta angle that is made with B vector and R vector, then I will simply use the parallelogram law. This is B, this is A. Let's say this is beta angle, this is theta angle. This theta angle will be again theta here. I will extend this line B, and this will become 90 degree. Now the perpendicular upon base will be tan beta. This is simply A sine theta upon A cos theta plus B. This is a way to remember sine upon cos. This is the order. So tan beta is equal to A sine theta upon A cos theta plus B. The angle made with any vector B is equal to the magnitude of the vector, this other vector, into sine theta upon magnitude of the other vector into cos theta plus the vector's magnitude itself from which the angle is made. Similarly, we can write tan alpha as the other vector, which is B, then sine theta upon B cos theta, then the vectors with which angle is made, which is A. So I can write the sum of vectors AB as this. So this is simply how to write the vector sum. Now we will move ahead and talking about sum and difference of two vectors. Let's say any point we can write in this section. Let's say difference and sum. So if we have let's say this is A vector and this is B vector making theta angle here, then let's say this is A, this is B. This vector from B, this is again A, this vector is A plus B, and let's say now this is A vector, this is B vector. Now then this, in this case, this is the head of both vectors. The joining head of both vectors will give A vector minus B vector or B vector minus A vector. Similarly, in this case, joining the tails, simply adding the both vectors like this, we'll get either A plus B vector or A plus B minus vector, that is minus A minus B vector. means the vector can be pointing in this direction or in this direction, depends on what we want. The sum of these two vectors of these two diagonals will be pointing in this direction, while the difference can be positive or a minus b or b minus a. If it is a, let's say if it is b minus a, then we will take b minus a in the opposite direction and add this vector pointing from this to this direction will be b minus a vector. And if I take a minus b vector, then I will take b a here and then minus b, then this vector will point in opposite direction. The a, a minus b vector will point in this direction. So this was kind of our first topic, first two things. Now moving ahead, we have another thing called writing a vector as sum of two other vectors. This will be third point. Third point is writing a vector R as in terms of a vector b vector, where a comma b, these two vectors are non-collinear. It is a must condition that these two are non-collinear vectors. If a and b are non-collinear vectors, let's say this is a vector and this is, let's say, b vector, then I can write any vector in space. Let's say there is an r1 vector here, r2 vector here, r3 vector here. I can write all vectors in this space using these a and b vectors simply by this r vector is equal to lambda 1 a vector plus lambda 2 b vector. By changing the values of these two constants lambda 1 and lambda 2, I can get different vectors in the space. I can obtain all the vectors where lambda 1 and lambda 2 belong to real numbers. These are constant values. So this is just a statement simply that you can write any vector in terms sum of two other vectors which are non-collinear. So this is a vector and this is a vector. Taking the sum of these two vectors will give this resultant vector R. Now it gives a special case which is important for us, which is let's say we have a vector equal to b vector's magnitude of equal and a vector perpendicular to b vector, means magnitude of all three vectors is equal and the vector a is perpendicular to b, then इसमें हमारे पास